Alright, I'm filming the second of our special topics for Chapter 4 on quadratics. This is all about going between the two forms that are key for working with quadratics. If we have something in vertex form, it's easy to sort of FOIL it out and expand it and then go into standard form. But now we're going to do the reverse. And if you were to try a couple of examples like we've done in class, you might see sort of what the pattern is, and it might make sense to undo it then. But what we're going to do right now is we're going to start with this one that's in standard form, and we're going to try to get it down here into that y equals sum a times x minus h squared plus k, where then our vertex will be h and k, and a will give us a clue as to how much it opens up or down. Okay, so the trick here is we're going to start by writing this as y equals, and then we're going to take these variable terms and factor out whatever the coefficient is for x only. So I'm going to take and write it 2 and then x squared minus 6x, and then I'm going to go right here plus 8. Okay? What we're doing is we're getting x squared so that it has no coefficient, because the next step is the completing the square step, and I'll talk about that in more detail in class, but I want you to show how you do it here. And that is, we have y equals 2 and then x squared minus 6x, and then we're going to write plus, always plus, some unknown number, and then out here it's going to be plus 8 and then minus whatever this number is here, 2 times whatever that number is there. These are always going to be the exact same number. What we're doing is we're adding it inside, and then we're just subtracting it over here. So if it's 10 that we're adding inside, we'll be subtracting it, and the equation will always be balanced. We're never just like taking a number out of thin air and then piling it on here. We're adding it and taking it away. So our equation does not change. We're just doing this clever little trick to make this into a perfect square. Now, if you have any binomial, x plus 7, for instance, and you square it, and you do the actual foiling, x plus 7 times x plus 7, and you FOIL that out, right? Then you should maybe pause the camera and do that. You're always going to get the same pattern. It's always going to be x squared. It's always going to be this second number at the end squared, always plus, because if those are two minuses, they multiply and make plus. If they're plus, they stay plus. And then it's always double whatever this number is, because it's 7 times x twice, so it's plus 14x. So there's always a relationship between these two numbers in that it's half of this number squared. Half of 14 is 7, squared is 49, and it comes from the fact that we've got 7s there and the way foiling works. So I want to take half of this number and then square it. Half of 6 is negative 3. When I multiply negative 3 times negative 3, I get a positive number, always positive. Positive 9 goes in there, and I write positive 9 right there, because I've got the subtraction sign right there, and so that's going to take care of keeping this balanced. I've really added 18 to here, so I'm adding 18, or subtracting 18 rather, from right there. Once I've got it in this form, it's always going to be then y2, and I've got this made into a perfect square, so if I factor this, it's always going to be the same two things. In this case, it's going to be x minus 3. And again, we'll practice this in class, but work through it and you'll see that it's always going to be half of that number there, just like half of 14 up here was 7. And then I do the math. 2 times 9 is negative 18. Sorry, negative 2 times 9 is negative 18. Plus 8 minus 18 is minus 10. So you can see now I've got this into our special vertex form, where when I go to graph this, I know that the vertex is at plus 3, 1, 2, 3, down 10, 5, 10, there it is. I know it's opening up. I know that when I cover that up and make the x's 0, it's at positive 8. So it's opening upwards and crashing up here at 0, 8. It's not really drawn to scale. I can find the symmetric point, and I can extract the square roots, and I can find those other 2 points for my 5 points of a parabola. But these are the steps that we use to complete the square and put a standard form quadratic into vertex form so we can graph it easily. Thanks.